Hello friends, welcome back to my channel Quality Magnify India. I myself Deepak Kumar Shamal welcome you all to my channel. Hope whatever the video I have uploaded earlier regarding API 510, 570, 653 and other technical related videos as well as some audit related videos, you are watching those videos and getting benefited from it. There is a personal request for all of the viewers, please subscribe to the channel in order to grow this channel more and more and give me more confidence to make more technical related videos which may help you in your professional career to grow further. And as you know, we have started API 653 training course from the last slide, part 1 I have made. And on that, if you didn't watch it, please do visit that video and watch all the related part which I have already uploaded for API 653. There is some introduction part and some sections, section 1, 2, we have already discussed on part 1. So today, for API 653 training course, we study, as I told you earlier, for reading API 653, for better understanding of API 653, you need to understand API 650 first. 650 is the construction of the tank. So if you understand 650, then it will be easier for you to understand 653 in a better way. So for API 653 last part, we have studied two chapters for API 650. Chapter 3 is nothing, it is a normative references. So we'll in this part 2 episode, we will study chapter 4 and 5, which I believe the most important, and you will get almost 6 to 7 questions from chapter 4 and chapter 5. So chapter 4 is for material and chapter 5 is the design part. What are the material selections usually we do for API 650 and how the design is calculated for API 650. Okay, so chapter 4, as I told, 2 to 3 questions is expected. Okay, so there are some bullet points which I have highlighted and underlined. So those bullet points you need to remember, and underlined points and highlighted points, the important points which we discuss, you have to make note or watch the video and make a note of that and practice several times so that you will get it remembered and can answer those properly in the exam. What happened? Usually these API exams are tricky one. The questions they put are usually tricky. Sometimes if you see, if you saw my earlier videos for 510 and 570, there are a lot of questions which will come like lesser than, equal to, greater than. Okay, the thickness of the material, thickness of the base plate should be lesser than, should be equal, should be greater than. These small tricky words, you have to remember it again and again. Neither what will happen. Sometimes you practiced it, but when you go to exam you got confused, okay, and you lose the mark. So for those reasons, usually what happen for preparing API 653 or 510 or 570 courses, we need to practice it again and again and again to make a thorough understanding and to remember it correctly. Okay, so let's start chapter 4 material, which usually there is 2 to 3 questions every API 653 exams it is coming. So let's start for materials. What are the materials usually used for construction of a tank? Rimmed and craft steels are not permitted. What are the steels? Usually what happen, there are 4 types of steels: rimmed, capped, semi-killed, killed. So killed and semi-killed are higher grades and rimmed and capped steels are lower grades. So these steels are not permitted. So that's why I told you, if there is a question came, which type of steels are avoided as per API 653, one is rimmed, one is capped, one is rimmed and capped, and another one is killed and semi-killed. So you have to check for rimmed or capped. So this or is also important. Okay, sometimes or and make some confusion. Use of cast iron for any purchase part or any part attached to the tank by welding is prohibited. So these terms are important and we have to make a note so that if any question came regarding to that, we can answer it. Okay. because of hydrogen embrittlement. Hydrogen embrittlement, when it will happen? When there is a welding. Okay. And toxicity concerns. Cadmium plate components shall not be used without the expressed consent of the purchaser. See, if you see all the codes, API codes, you will find they give more emphasis, more value to the purchasers. The purchaser can decide lot of things. The code give flexibility to the purchasers. Purchaser is the owner. They give a lot of flexibility to the owner. The owner has to decide in many cases the owner has to decide whether he will allow or not allow. The code will give a flexibility for the owner. So here what is saying, cadmium plate components, that is usually when you do the welding of cadmium plate components, the toxic fumes will come. Extra safety required for that one. So he is telling because of hydrogen embrittlement and toxicity concerns, hydrogen embrittlement happen. If hydrogen embrittlement will happen, the weld will crack. Okay. So cadmium plate components shall not be used. Material used in the construction of tanks shall conform to the specification listed in the section, subject to the modification and limitation indications in the standard. Material produced to specification other than those listed in the section may be employed, provided that the material is certified to meet all the requirement of an applicable material specification listed in the standard and the material use approved by the purchaser. So as I told you, if there is any material which is not listed in API 650 and the purchaser want to use, then they can use. Okay. When any new or unused plate on pipe material cannot be completely identified by record that are satisfactory by the purchaser as material conforming to the specific listed in the standard, the material or product may be used to construction tank covered by the standard only if the material test certificate by Annex N. There is Annexure N. If some material you have purchased and that material you don't know the traceability of the material, what type of material is there, no MTC number, no heat number, nothing, then by Annex N you need to carry out certain tests in order to identify that material and use in your construction field. So Annex N, you have to remember, many times this question came in API 653. I will tell you one thing. You know the group of materials, okay? If I will tell you ASTM A36 or any other type of material and I will ask you which group number it is. So might be you will remember for ASME section 9, okay? ASME section 9 there is a group number. If you didn't know about those group numbers, P number, G number, A number, if you don't know that, please visit my previous videos where I have explained what is P number, what is F number, what is A number, what is G number, what is S number. So you are thinking about those group numbers which is given in ASME section 9. But for API 650, the group number is little bit different. Okay, it is group 1 to 6. It is not P number 1, 2, 3, 4, not like that. It is group number 1 to 6. Usually what happen? Group 1 to group 3A, they consider it is low grade, and group 4 to group 6, they consider it is a high grade. I will show the group details and everything further. So there is some calculations usually come. It's a must question for API 650 where it came related to group number question is there. Regarding the design temperature, if you remember design ambient temperature, that calculation I will just show you after 2-3 slides. That question usually came in the exam and it is a must question. Okay, so when a tank is designed to the requirement of a standard using plate material group 1 through group 3A, the tank manufacturer responsibility for any proposed material substitute to use through must do the following. If you are going to use any group 1 to group 3A, okay, the tank manufacturer responsibility for any proposed material substitution to use group 6, group 4 to group 6 must do. So what are the substitution? If I use group 1 to 3A instead of group 4 to 6, what are the substitutions? Maintain all the original design criteria for the lower stress 1 through group 3A. If you will ask me, sir, this group 1 to 3A is the lower one and group 4 to 6 is the higher one, as you told. So if I use group 4 to 6, it is better than group 1 to 3A. So why I need any approval? No, there is some requirement. If something happened like that in any situation, then you have to maintain design criteria for all lower class groups. Okay, and you have to obtain approval from the purchaser. Purchaser means owner. As I told you, purchaser is the owner. So you have to take approval from the purchaser. Okay, an underrun not more than 0.3 mm or 0.01 inch from the computer design thickness or the minimum permitted thickness is acceptable. This is important. Usually it came in a closed book question. Okay, what do you mean by underrun not more than 0.3 mm? Let's say you order some plate which is 8 mm thickness. Okay, and up to how much you have allowed? 8 minus 0.3. Okay, less than that thickness is not allowed. So that's what it is saying. An underrun not more than 0.3 mm from the computer design thickness. This is the design thickness. Less than 0.3 only we can allow. More than 0.3 we cannot allow. Okay. Cell plate are limited to a maximum thickness of 45 mm or 1.75 inch. So what is the maximum cell plate thickness as per API 653, which allowed is 45 mm, 1.75 inch. Unless a lesser thickness is stated in the standard or in the plate specification. Plates used as thickened insert or flange may be thicker than 45 mm. Designed by 4.2.10.1 and thicker than 40 mm. So he is telling basically what is the requirement, material requirement. Okay, material requirement one by one we are discussing, and here he is mentioning cell plate thickness, the max you can use 45 mm. Okay, all welding performed by repairs surface shall be made with low hydrogen, compatible with chemistry, strength, quality with the plate material. Any welding or repair of the welding, if you are doing, that should be done by low hydrogen electrodes. Okay, not high electrodes, 7018. Okay, 7016. These are low hydrogen electrodes. So we have to use with the low hydrogen electrodes. Impact testing of plates. If in any reason impact testing is required, then what we have to do? Impact testing, why we do? Impact testing is required if it is if the tank is working under lower temperature. During lower temperature, the material is brittle, okay, and it can break. So to check, in order to verify the impact test, if the tank main liquid or storage of liquid is in lower in temperature, he is asking some requirements when we need to do the further impact testing. So when required by the purchaser, Charpy V notch impact specimen shall be from plate after heat treatment. This is important. After heat treatment only. Okay. If plates have heat treated and the specimen have fulfilled the stated energy requirements, then you have to go for the impact testing. An impact test shall be performed on 3 specimens. You have to remember all these things. 3 specimens. We call it one set, 3 specimens. From a single test coupon. You cannot take different coupons in one single test coupon. The average value of the specimen, the average value, let's say one is 20, one is 30, one is 40. So average 40 plus 30 plus 20 divided by 3. So the average value of the specimen with no more than one specimen value being less the minimum value. What is saying? With no more than one specimen value being less than the specified. I explained in the next slide. You can see there how we can accept the impact test requirements. Okay. So if say let's say there is 2 values, 3 values of the impact test is coming 20, 30, and 40. Okay. You have to check for that particular material what is the minimum impact test requirement is there. That is in the table. I will show you in the table. Okay. And if is telling average of 3 should come 30. Okay. Should come 30. Code says average of the value should come 30. So what we will do? 20 plus 30 plus 40 divided by 3. Okay. So it is coming 30. So we can tell is accepted. But one of the value, okay, they are calling the lowest one. The lowest one should be within 2/3 of the average. Within 2/3 of the average. 30 2/3 is how much? 20. If this value is 18, let's say this value coming 18, 30 and this one coming 45, then straight away we have to reject it because this value is lesser than 2/3 of the average value. Did you understand it clearly? Let me explain one more time. First impact test value 20, 30 and 40. Okay, and as per my code it is saying for that particular material the average should come 30. Okay, so what I do, 20 plus 30 plus 40 divided by 3. Okay, and I found the value is 30. At this stage it is accepted, but in another one stage, if 20 becomes 18, okay, and 40 become 45, at that stage even though my average reaches to 30, but the lowest value is not meeting 2/3 of the average. Average 2/3 is 20, but it is coming 18. That's why it is rejected. So in that case, you have to do re-impact testing with a new complete set. Okay, so that's what it is asking, and you have to remember it very carefully. Okay, so that's what it is written here. If more than one value is less than the specified minimum value, or if one value is less than the 2/3 of the specified minimum value, 3 additional specimens shall be tested, and each of these must have a larger value than the equal of specified minimum value. Larger value. Okay, you understand? 2/3 of the minimum value. So the CHRP impact test is done as per ASTM 370, that you have to remember, this is important, and the sample is 10 mm by 10 mm sample usually they made, and sometimes if 10 mm is not available, 80% of the material thickness it should cover. Okay, if in any case 10 mm by 10 mm sample is not possible. So here I have mentioned here, let's say any group 1 to 3, 1 to 3 a material, okay, T thickness measurement, whatever it is mentioned. Okay, so for that one average impact value is already mentioned here, 15, 30, 40 less than 1.5, T less than 1.75, and it is 50, it is mentioned here. So what you do, you take 3 samples and do the testing, take the readings. After taking the readings, compare table 4.5b, okay, which is minimum impact test requirement for plate, USC, United States code. So this USC, there is 2 codes actually in API 650. You can see this is SI code and USC code. Okay, don't use the SI code, it is in millimeters and everything, but use USC code, that is in inch, foot and everything. So that will be easier for you to understand. Okay, so what happened here, as per the as I told you in API 650 the group is different, it is group 1 to group 6. Okay, so for lower grade I told group 1 to group 3A. So for lower grade, what is the average impact value, it is mentioned here. Okay, there is 2 way. Okay, longitudinal and transverse. Longitudinal, in the lengthwise if it is the impact test is done, and transverse if in the widthwise it is done, it is transverse. So for that reason it is already given what is the values, average values. So based on that you have to find out your specimen and take the readings, then you have to find out whether it is accepted or rejected. For your better understanding, I have here mentioned it in a short way, so that you can understand. The specification is a 370, specimen size is 55, 10, 10 mm. Number of specimen, usually one set, we call it one set, 3 numbers. Usually longitudinal transverse values from table 4.5b, this is 4.5b. First time test. Okay, first time test, what will do, 1 specimen below average is acceptable, but 2 specimen below average is rejected. If 1 specimen first time test you are doing, first time test below average is acceptable, but 2 specimen below average is rejected for the first time test. Any specimen below minimum is rejected. Minimum, below minimum is 2/3. Okay, below 2/3 is rejected. That you have to remember. This is very important. Any specimen below minimum, minimum means 2/3 of average. Okay, for any of the above situation, go for the retest. If something happened like that, 2 specimen got below average and any specimen below minimum it went, then a retest will be done. And for retest, all impact test specimens should be equal to or greater than the average. Just remember this one, it is very important. For retest, for first time test, We allow up to 1. But for retest, not a single specimen will be allowed below go average. Okay. So USC code, as I told you, is United States customary code. So as I told you, group 1 to 3, okay, that you have to remember, that is the low grade, okay, and group 4 to group 6, this is higher grade. But here also you have to see one more thing in this group. Why there is group 1, group 2, group 3 and group 3A? What is the difference group 3 and group 3A? There is a very important difference. You have to remember it, and in some questions, if the question will come, you have to take the group selection accordingly. Okay, and this is very, very important. Group 3 is as ruled killed. Okay, group 3A is normalized killed. Okay, normalized means heat treatment was done. As ruled means there is no heat treatment. So you have to select it very carefully. When there is some question will come, API 516 grade 60. You see, API 516 grade 60 is here and grade 60 is also here. But here it is 3A, here it is 3. Why? Because in the question maybe it will mention API grade 16 dash 60 as rolled steel. API 516 dash 60 normalized steel. If it is normalized steel, you have to select group 3A, and based on this group, the chart, there is another one chart will come. You have to select the readings based on the group 3A. If you select a wrong group, then your values will be wrong. Okay, so check for this as rolled and normalized. Be careful for that one. So to determine the minimum design temperature of the material, as I told you, you have to check for the as rolled and normalized materials. If there is any material and it is asking that material this much thickness, what is the design metal temperature? For that reason, what you will do, you have to find a equation which is given in the table 4.3. This question is a 100% must question in API 653 examinations. So when they mention API 560-16, here there is something missing, I forgot to write. If it is, they have written normalized or edge rolled. So which one is mentioned, that you have to check. So when you find this one, you have to find out by checking the material, you have to find out which API group it is coming under. Okay. Once you find the API group, then you have to check the thickness range. This is the thickness range. Okay. Here I have mentioned 1 inch. So let's say I found out this one. Here it is normalized steel. Okay. Sorry. So here it is normalized steel. So for API 516 grade 60 normalized steel, it is 3A. Okay. So I went for 3A. So 3A, what is my material is 1 inch. So X is the thickness. Okay. X is the thickness including corrosion. Okay. So X is thickness. X is saying 1.5 to 0.25. So for that one, there is an equation Y is equal to minus 40. Here straight it is saying. So Y is design metal temperature. So I can write here Y is equal to minus 40. So I can write Y minus 40. But here if you see 3A, and here I mentioned as 3 edge rolled. Okay. Here I mentioned is edge rolled. We will do in both ways. Okay. We do in normalized and we do in edge rolled. For edge rolled, it will come in 3, group 3. Just see why I was telling to check the group number for normalized and edge rolled. Usually the question come from this table only, 3 or 3A. Okay. So for 3, if I see my 1 inch material, number 3, 1 inch is not here, 1 inch is here. Okay. So the equation is Y is equal to 60x minus 70. So X is the thickness. So minus 70, it is coming minus 10 degree. So this question usually came in the open book and it is a must question. So be careful for that one and you have to do it. There is two ways to find out the minimum design temperature of the material. The first way is to get the equation and to do it. Another one way is the chart. The next slide. You see the chart is here. So once you find the group of the materials, let's say group 3, group 4, group 5, then you have to check the thickness. What is the thickness it was given? 1 inch, okay? So 1 inch, 3A, I have to find. So it is coming minus 10. See? So last slide, if you see, we have found out. So minus 10, 1 inch, and this. So by the chart you can do it, and by the calculation also do it. It is an alternate way. If you remember, I have told you in my part 1, that is last 2-3 slides, as I told you, there is an open book question. So practice it and do it carefully, so you will get one open question for sure. This is another one, must open book question, okay? Design metal temperature, how you will find out by isothermal lines of lowest 1-day mean temperature. What I told in the part 1, you have to add 15 degree F. 15 degree F to find the design metal temperature to that location, that particular location, lowest 1-day mean temperature. In APA 653, they have given a US Weather Bureau and Meteorological Division Department of Transport and Domination of Canada records up to 1952. So what they do, they mention one US Weather Bureau weather chart. In that, some locations are mentioned, and on that location, what is the lowest 1-day mean temperature, that was also mentioned there. Okay, so it will ask in the question, either it will ask what is the lowest 1-day mean temperature, you have to go to the chart, you have to find it out, and you have to write figure 4.2, or sometimes it asks design metal temperature. What is the design metal? So don't confuse yourself with the design metal temperature and lowest 1-day mean temperature. Lowest 1-day mean temperature, directly go here and find it is 20 degree, 25 degree. Okay, Los Angeles, this is 35 degree. Okay, San Diego, 35 degree. Okay, you have to go one by one, then you have to find out the location. Miami, it is 45 degree. So this temperature exactly I will go there and I will find out. So this is lowest 1-day mean temperature, but design metal temperature when it comes, so I have to add 15 degree F to the lowest 1-day mean temperature. So how much it will come? That is the design metal temperature. You will find one question for sure from this design metal temperature. Okay. Then we are continuing with our materials. So lap joint flanges shall not be used without the approval of the purchaser. That is true. As I told, purchaser has all the powers. So those joints is not possible, not to be used without the approval of purchasers. Okay. Gaskets. Seat gaskets shall be continuous. If you are using seat gasket, that shall be continuous. Metal gasket made continuously by welding are acceptable if the weld is ground flush and finished the same as the non-welded portion of the gasket. Metal gasket you can use, and it can be made continuous by welding. As if there is 2 metal gasket, you can weld both the metal gasket and you have to flush grind, and that is acceptable. Welding electrodes. What are the electrodes you can use? The minimum tensile strength not less than 80 ksi. Okay. Manual metal arc welding shall conform to 60 and 70 specification series. All should be AWS A5.1. For welding of material with minimum tensile strength of 550 to 585 MPa, the manual arc welding electrodes shall conform to 80 series classification series AWS A5.5. So this is the material requirement. So chapter 5 is the design part. So we have completed the material part, and I believe APA 650 chapter 5 is the toughest one, and it cover around 3 to 4 questions. Okay, but there are many terms you have to remember. I have highlighted those terms. You have to exactly remember those terms, and you have to understand APA 650. Well, so let's start from the design part. In the design, they mention from bottom plate, cell plate, roof plate, nozzles, openings, attachments, what are the requirement for those. So the design will explain all these things. So chapter 5, we expect 3 to 4 questions. Let's start with fillet weld, a weld of approximately triangular cross section. This is the definitions. Full fillet weld, a fillet weld whose size is equal to the thickness of the thin joiner part is called full fillet weld. You have to remember that. Tack weld, a weld made to hold the part of weldment in proper alignment until the final weld is made. Why I mentioned all these points? Usually in closed book, sometimes it came. There will be a term in the question, a weld made to hold the part of weldment in proper alignment until the final welds are made is called tack weld, full fillet weld. So you have to choose the right answer. Sometimes it came. The minimum size of fillet weld shall be as follows. On plate 5 mm thick, the weld shall be full fillet weld. You have to remember this. And plate more than 5 mm thick, the weld thickness shall not be less than 1/3. 1/3 of the thickness of the thinner plate at the joint and shall be at least 5 mm. Okay, that you have to remember. Lap welded joints, a stack welded shall be lap dash fold. How the lap welding joint will be happen? Lap means one plate overlapping another one plate. Okay, and the welding will happen here and here. Okay. So this is lap welding. Sometimes single welded lap joints, double welded lap joints. So it is saying double welded joints shall be lapped at least 5 times the nominal thickness. How much the nominal thickness is? 5 times of this of the thinner plate joint or 2 inch, whichever is smaller. Okay, lap joints should be done like that. And single welded joints shall be lapped at least 5 times the nominal thickness of the thinner plate joint or 25 mm, whichever is smaller. As I told you, group 4 to 6, self bottom plates of all weldings, all welds shall be using a minimum of 2 passes. This is very important. All high strength plates 4 to 6 should be welded with double pass, multi pass. Okay. Vertical cell joints. Vertical cell joints butt weld should be complete penetration. Very important. All cell plates should be complete penetration. Okay, by double welding or other means that will obtain the same quality of the deposition weld metal on the inside and outside weld surface. So for cell plate joints, it should be complete fusion with double welding, both side weldings. Okay, so if the weld is like that, double B, then you have to weld on both sides, this side and this side. Okay, if this is the plate like that, so both the side the welding should be there and it should be a complete penetration. A penetration is must. Okay. So vertical joint in adjacent cell core shall not be aligned. What does it mean? This cell, okay, this is one cell and this is one cell plate. This vertical joint and this vertical joint should not be aligned, should not be in one line. It should be separate. How much separate? A minimum distance of 5T. This is important and usually come in the exam. Usually 5T, where T is the plate thickness of the thicker course of the point of the offset. Okay. 3 plate lap or tank bottom shall be 300 mm or 12 inch from each other. This is very important. 3-point joint means this is 3-point joint. This 3-point joint and this 3-point joint should be at least 300 mm or 12 inch apart, 12 inch separate. It should not come more than 12 inch. So here it is a lap joint as I saw for the bottom welds. You can see this one. For method of preparing lap welded bottom plates and tank cells, how it is happened, it is for your knowledge only. You have to check and you have to see. There are some requirements how it happened. Butt welded bottom joints, what are the requirements? Backing strip you are using, it should be 3 mm thick. Okay, butt welded bottom plates shall have their parallel edge prepared for butt welding with either square or V groups. Butt welded shall have been used with using a appropriate butt joint configured that yield a complete penetration welds. So these are the requirement for the double fillet groove weld to annular plate bottom plate with nominal thickness greater than 13 mm. So these are the requirements, which is not so important, but for your knowledge you have to know that. Okay. Cell to bottom fillet weld. What is the fillet weld is requirement? Usually this question is coming in the open book. In open book. Okay. I will not go in detail, but you have to remember what is the nominal thickness of the cell plate and what is the minimum size of the fillet weld it is required. So if a nominal thickness of the cell plate is 0.1875 inch or 5 mm, the minimum size of fillet weld is required 5 mm. Fillet size is required. Okay, fillet weld size is 5 mm. The bottom of annular plate shall be sufficient to provide minimum 13 mm from toe to the fillet weld reference to the outermost side of the bottom or annular plate. What does it mean? Let's say this is my tank bottom plate, this is my cell plate, and this is the fillet weld. So after fillet weld, he is saying what is the distance will be, that distance should be 13 mm minimum. This is one question usually come in the APA 650 exam. Okay. Roof and top angle joints. For frangible roofs, roof plates shall be attached to the top angle to the tank with continuous fillet weld on the top. What is frangible roof? Do you know that frangible roof? Frangible roof is something which is welded with the cell plate, one-sided fillet welded. Okay, this is done usually because to give extra strength for the bottom plate. Usually what happen? Let's say this is the bottom plate. Okay, this is the bottom plate and this is the cell plate. We are doing welding here. During some time, due to stress or something, this stress will happen with the bottom plate and cell plate joint, and here some crack can occur. So for that, if the roof is welded with one side fillet weld, so the stress is distributed here and the fold stress is not impacted with the bottom plate area. So the chance of crack will not happen. The crack may be happen here. If the crack will happen here, no problem. Yeah, this is the tank. The tank is filled with liquid. If the crack will happen here, it is okay. But if the crack will happen here, it is not okay. So that's what it is saying. It is called frangible roof. So those roofs are called frangible roofs. Frangible roofs, the fillet weld in one side, okay, one-sided fillet weld. Only one-sided fillet weld, not double-sided fillet weld. So similarly, what is the top angle for the roof? It is mentioned here. You have to remember it can be a open book. So you have to remember the open book questions. Where to find out all this you can find out in chapter 5. What is the thickness? What is the fillet size? What is the top angle, minimum top angle? So here it is mentioned. If the tank diameter is this much to this much, the top angle will be in mm how much and in inch how much. Okay. So loads. What is dead load? The weight of the tank and tank component, including any corrosion allowance, unless otherwise noted, is called dead load. Dead load means there is no liquid inside. Okay, the tank weight itself is called a dead load. Tank that meet the requirement of the standard may be subjected to a partial vacuum. This maybe it is asking for what is the partial vacuum. As I told you, for APA 650, already I explained in part 1. What is the pressure for APA 650? 2.5 psi. Okay, more than 2.5 psi to 15 psi. It is APA 620, not 650. So that's what it is saying. For design internal pressure, it should not exceed 2.5 pound-foot per inch square. Okay, 2.5 psi. Hydrostatic test. The load due to filling the tank with the water for design liquid level. It is called hydrostatic. Hydrostatic test we will read in further chapters when we will. Go for next part. We will discuss about hydrostatic test. Hydrostatic, there is no pressure in this tank. Okay, tank is not tested with pressure, just atmospheric pressure. They fill the tank, they keep it for 24 hours, and that's it for it. It's called hydrostatic test. So here there are some basic terms I have mentioned from which you can get to understand. Top of the cell height, design liquid level, normal fill level, minimum fill level, top to bottom plates. Okay, so these requirements, this is only for your knowledge, not for any questions in your exam. So any hardness criteria, hardness test, any hardness criteria should be a matter of agreement between purchaser and manufacturer. This is again comes to the purchaser account. So if there will be any requirement for hardness, so the purchaser and the manufacturer has to decide if it is required or not. And what is the hardness requirements? Weld metal and heat affected zone hardness shall comply with H2S supplemental specifications. When specified by the purchaser, the hardness of the weld metal cell materials in group 4 to 6 shall be evaluated by one of the following methods. What is the method? How, if let's say they decide, okay, group 4 have high grade materials, group 4 to group 6, we have to do the hardness. So what is the requirement? The hardness should be done in the product site. What do you mean by product site? So if this is the tank, if this is the tank, inside is called a product side. Okay, inside is called product side. So unless otherwise specified, one test shall be conducted for each vertical weld. There are vertical welds because there are cells. Okay, so there are vertical welds, there are horizontal welds. So for each vertical weld, one test should be done. Every vertical cell, one hardness testing must be done. That's what it is saying. And for each 30-meter circumferential shall be conducted for each 30-meter circumferential weld. So so what is saying, one test shall be conducted for each vertical weld and one test shall be conducted for each 30-meter circumferential weld. So for vertical weld, each vertical weld I will do one hardness test, and circumferential weld for all circumferential weld for 30 meter or 100 feet. Okay, I have to take one. Clear? This question usually came in the exam. For hardness testing, vertical weld, every vertical weld one joint, and every circumferential 100 foot one joint. Okay. Thickness. When 6 mm thick material is specified, thick material may be used in the US customary purchase approval, similar for 5 mm for thick. No, it's usually saying what is the thickness of the bottom plate, what is the cell plate, and what is the roof plate. There is a 6-5-5 rule. 6 mm thick for bottom plate, 5 mm for cell, and 5 mm for roof as per API 650. Bottom plate. Okay. Unless otherwise specified by data sheet, tank bottoms requiring sloping shall be a minimum of slope 1 to 1:120. This is very important. You have to remember. There is sometimes question came in the open book. What is saying? Let's say this is my tank bottom. Okay. I just made it. It's not perfect. Anyway, this is the foundation. So this slope should be 1:120. 1:120. Okay. This slope should be 1:120. That's what it is saying. So sometimes the slope is outside, sometimes the slope is inside also. Many bottom plates can be like that. Okay. And you have to put a sump pit somewhere here. But here the sump pit is here. Okay. Maybe 2-3 sump pits they can give near to the cell. Okay. So here there will be one open book question may come. If the tank dia is let's say 100 feet, okay, tank dia is 100 feet, then how much slope will be there? So you have to calculate 100 feet. So dia 100 feet means the radius is 50 feet. So 50 feet 1:120 you have to calculate and you have to find how much slope will be there. Okay. This question usually came in open book. Drip ring. This is very important. It's usually the purchaser decision if you want to make it or not. Why drip ring is, what is the requirement of drip ring? It is to avoid the ingress of water inside the bottom plate. Okay. And for that reason, a material of carbon steel 3 mm usually thickness is attached to the bottom plate and it bend downwards. What is the requirement of the drip ring? It is mentioned here. Okay. So you have to remember all these things. Drip ring. Annular bottom plate, what is the calculation? This calculation never came. Okay. But you have to remember sometimes maybe it comes. Okay. There is some requirement is there, but usually it never come in the exam. What is the requirement for annular bottom plates? It's a design criteria. Annular bottom plate thickness. How we can make? This is an open book question. There is nothing to calculate. Only go to the table and you have to find out. How you can find out what is the annular bottom plate thickness? He will ask you, find out the annular bottom plate thickness. Okay. If the plate is this one fast cell course, okay, thickness of the fast cell course, if the its stress value is less than 30,000, okay, then you have to find out. So what will be the annular plate thickness values? So you have to go what is the thickness value and how much it will tell you the first cell course thickness. Okay, the first cell course thickness how much, and it will tell what is the stress value. So by comparing this one you can find out what is the thickness of annular bottom plate. Okay, that's what they are asking. Let's say they say 1.1 inch. Okay, the past cell course is 1.1 inch and the stress value is 34,000. So it is less than 36,000. And what will be the annular plate thickness? So 9 by 16 inch. You have to find out, you have to know the table where it is. Okay, open book is nothing to find out a table where it is. That is most important. You should know where the table is. Calculation thickness for 1 foot method. Okay, honestly saying, this 1 foot method is more important in as per API 653. In API 650, usually this question never comes. Okay, 653 usually this question will come, but although it is like that, you have to remember these two formula. These two formula will come in API 653. We will read it again. 2.60 H minus 1 G by SD plus CA, CA corrosion allowance. Okay, this H minus 1 is 1 foot method. Okay, he is telling if there is a tank and there is some cells. Okay, let's say 1, 2, 3, 4, 5. So 5 cells are there, and when we calculate the height of the cell, okay, let's say this is total is 50 feet. Okay, and each cell course is let's say 8 feet. Okay, it is coming here because there is a roof. So it is somewhere here. Design fill level is up to here. Okay. So for that one, if above 1 foot, 1 foot of each cell, if we will calculate, then that thickness TD, design thickness TT, this is a hydrostatic cell thickness. Okay. This thickness value which will come, it is same for the entire cell course. That is called 1 foot method. Okay, design point, it is written here. A 1 foot method calculated, the thickness required, a design point 0.3 meter above the bottom of each cell course. So above the bottom of each cell course, we calculate 1 foot method, and it is same for all the thickness value. Okay, by this we calculate the TD, design thickness, and TT, hydrostatic test cell thickness. Or there is another one method by which we can find out by going to the table. Simple by table. Nominal tank dia how much and the plate thickness will come how much. Okay, and it can be possible with the sometimes it asks for the group number, and it's when where you will find this SD values. For SD value you have to go table 5.2.b. we will check this one in 653. Here I think it is not so important for you to do these calculations. In API 653, there is a maximum of 20 questions, 20 to 25 questions come from 650. Okay, more the calculation from 653. But open book, as I told earlier, these are sure short questions. Every time this will come. Cell opening, this is also a open book questions. This is also open book. This is an open book. You need to remember where it is. Okay, where it is and how it is coming. How? Let me explain in a short way. Okay. Here you see A, B, C, RTR, E, D, LTR, B. These are the openings. These are the manholes. Okay, these are the nozzles attached to the cell plate. Okay, so here it is saying cell plate thickness how much. Then they will ask in the open book what is the value of A. What is the A? A is reinforcing plate to vertical joint distance. B, reinforcing plate horizontally it is there, from there to the top circumferential joint, what is the distance? B. C, bottom side, what is the distance? E, from tombstone reinforcing joint for this nozzle reinforcing joint, what is the distance? E. Like that, all these things is mentioned here. You have to check this figure. Okay, cell opening, then go to the table, check the thickness of the cell plate. Then by referring that one, you have to find out how much is A, B, C, D, E, F, G, and you have to write the answer. So this is a complete open book question, and it is easy to do, but only you need to know where it is, where you can find it. Similarly, thickness of cell manhole is same. You have to see the drawing here. Here is the cell manhole. You can see this is the bottom plate, this is the cell plate, this is the reinforcing plate, this is the nozzle, and this is the cover. Okay, cover of the opening. Okay, So here the bolt torquings are done. Here it is its side view and it is the front view. Okay, here the bolt torquing is done. So this one, as per the height, equivalent pressure, everything it will ask you, and they will ask how much the minimum thickness of the bolt flange after finishing will be required. So based on that readings, you need to find out and go to the table to get the answers. There is nothing big on this one. Only you need to know where you can find in API 650. Most of the questions is from 5, section 5, which is design. So thermal stress relief. Stress relief is also required sometimes if it is needed. Again, it is the call of a purchaser. So what is the stress relief requirements? The temperature range between 600 to 650. It is required, okay, and 1 hour per 1 inch cell thickness it is required, okay. This is all flush type clean out fittings and flush type cell connections. For non-flush type nozzles and mainways, for group 1 to 3A, all openings NPS 12 inch or larger, the nominal diameter and cell diameter. So this is the requirement, 6 to 650. It is almost same, okay? It is almost same, but it is a little bit different as per the thickness and as per the group of metal. It is not so important, and maybe sometimes it can come in the open book questions. Cell attachments. Here there is some points I have mentioned which you need to read, and it is not so important for you. These include such as wind girders, stairs, gauging systems, davits, walkways, tank anchor supports for internal items such as heating coils and other piping supports, ladders, floating supports. So these are some of the requirements. You have to read it. Okay, it is not so important how the attachment is there, how the welding to be done, roof venting, why it is done. Roof venting, why it is required roof venting? Why it is required roof venting? You maybe know the vacuum creation, okay? The vacuum created for two reasons. First reason why the vacuum happen, if the drainage is not proper and the water is draining very fast, so the vacuum will occur inside the tank. Second, if you use some liquid and in winter it becomes solid, okay, and you don't have any arrangement for that one, then the vacuum can also be occurred, okay. Suddenly the liquid become solidified and the area is reduced and the vacuum can create. So that two reasons are there. For that, roof venting is required, okay. There is a valve usually we put in tanks. We call it PVRB, pressure venting relief valve, okay. Why pressure? If the tank is there, if you fill the water, the pressure, air pressure will reduce and it will make some pressure, so the valve will open and the air will go out, okay. And if you empty the tank, you remove the water, then also the outside air pressure and inside air pressure, there will be difference, so the vent will open immediately to balance both the pressure, so it is called venting. So it is called PVRB, pressure venting relief valves. Roof. How the roof will be? The following definition applying the roof design. How the roof can be done. A supported cone roof is a roof formed to approximately the surface of right cone that is supported principally either by rafters or girders. As I told you, there are three things: column, rafters, and girders. Okay, I already explained you. You can check there in my past video. Okay. So there are some frangible roofs, as I explained to you earlier. What is the frangible roof in my previous slides? You have so you can check there. Then supported cone roofs. Okay, the slope of roofs shall be 1:16. This is not so important, but sometimes the open book or closed book question they can ask. Okay, if specified by the purchaser, what is the slope for the roofs? Okay. Corrosion and abrasion. This is important. This is very important. You have to remember this. This is a closed book questions. Okay. Rafters shall be placed to satisfy. This formula is not so important. Okay. This is important. What happens when there is a tank? Okay. There may be one column or many columns. Okay. 3 or 4 or different columns as per the design. What is saying, at each column a wear plate with nominal thickness not less than 6 mm. So this column at the bottom we have to put a wear plate and whose thickness should not be less than 6 mm. Okay, and shall be welded to the tank bottom with a 6 mm fillet weld. So this is much required. So for all the columns, you have to attach a wear plate whose thickness must be 6 mm, and a 6 mm plate will be weld to be done. Why? Now, a single adequate thickness plate may be designed for the dual function of load distribution and corrosion abrasion protection. You have to remember this. This is usually come in the exam. Okay. So friends, we are continuing with API 653 part 2, and we have completed almost 50% of API 650. Rest one or two slides, two parts, we will complete API 650, then we will move to API 653. So as I told you, API 650, almost 20 to 25 questions are coming. You have to prepare yourself accordingly, and how much I have explained in my previous videos, I think that is more than sufficient to get all the questions. Okay, so no need to go for any other to take a coaching or something. Read the API 650 very carefully. Put the comments in my video if you have any doubt. Share it with your friends, and put comments, and please share with your friends in order to grow this channel further. I hope you like this video. If you liked it, please share, like, and comment, and do watch all my rest of the videos. Thanks for your time, and thanks for watching. Have a good day.